Alright, so today, finishing off our lectures on hormones, we've got the reproductive ones. So we're going to talk about estrogen, testosterone, and yeah, stuff like that. So shirt check, we've got Brighton Panthers, but sponsored by Jupiter this time. Yeah, nice top, and gets pretty sweet though. But yeah, let's move on. So we've got androgens, which are basically male hormones, but obviously women have them as well. But predominantly testosterone is what allows males to develop their secondary features, similarly in the way that estrogens allow females to develop their features. So androgen is kind of a collective term for the hormones as well as estrogen. So they're made in the zona reticularis of the adrenal cortex. However, they're not seen to have detrimental effects on the body. It's mainly from the ovaries and testes that these hormones have the biggest effect on. So they're made by this DHEAS through to DHEA, which we talked about, and they make androgens. So we've got these gonadotropes in the pituitary, which make LH and FSH in both males and females, and they regulate the gonad function, and that's seen on the hypothalamic pituitary gonad axis. So firstly, we talk about ovaries. We've got these granulosa cells which express aromatase, and aromatase basically turns testosterone into estrogen. And they also express the 70-beta HSD, which is, as you remember, needed for the conversion in the adrenal glands. However, it's also used here if you look at the diagram. So we've also got these fecal cells, which express 3-beta HSD and CYP17. And we remember CYP17 from the adrenal lecture as well. And also we've got these granulosa have FSH receptors to produce inhibin. Inhibin, what it basically does, it stops the pituitary from releasing more FSH and LH so we don't get overwhelmed. So fecal cells, they have these LH receptors and they produce the androgens, but then the granulosa cells use to make estradiol. And fecal cells produce androstenedione, which is made into the 17-beta estradiol in granulosa cells. So as you can see in the diagram, we've got LH coming into the receptor. Then we've got CAMP activating protein kinase A, and then allowing that cholesterol to be turned into androstenedione. So that's then turned through aromatase into estrone, and then we've got this FSH coming in to allow protein kinase A again, but in a different cell, to turn estrone into estradiol as well. So in the testes, so similarly, we've got Sertoli cells which express aromatase, and they turn testosterone into estrogen and produce inhibin. And Sertoli cells have FSH and androgen receptors. Then again, a Leydig cell express these enzymes here, as well as that one. And LH targets Leydig cells, which make androgens used by Sertoli cells to make estrogens, and with FSH to continue onto spermatogenesis. So that's very important. And testosterone is secreted by these Leydig cells with the help of LH. And testosterone travels via the sex hormone binding globulin in the blood. So as we talked about, that three-step system again. In the hypothalamus, we've got gonad releasing hormone, which allows pituitary to release this LH and FSH. FSH usually in slow pulses and LH in much faster. And both of these then attach to receptors and stimulate protein kinase A to start steroidogenesis and gametogenesis. So we talked about inhibin, which basically stops that action of FSH and LH, as well as testosterone and estrogen having that negative feedback effect on the pituitary and the hypothalamus. So if we talk about the effects of estrogen, so they help with those closing of epiphyseal plates, which we talked about in the somatotrophin lecture. That's why generally girls are smaller. And we've got increased expression of LDL receptors as well. They also promote vasodilation and increase nitrogen oxide. They also maintain smooth skin and promote wound healing. Progesterone, again, works with estrogen to maintain smooth skin, but also have got this increased production and inhibition of breakdown of collagen. Also affects the hypothalamus to affect thermoregulation. So if we talk about then the disorders, again, we can either have too little or too much. So we've got hypogonadism, where we have low androgen levels. And we can have amenorrhea in women, so that's absence of having a period, or that's primary, or you can have secondary, where you had a period and then it just suddenly stopped. And you can have also impotence, so infertility in men. An example there is Kalman syndrome, specifically secondary hypogonadism in men. Then we've got gynecomastia, and that's changes to the estradiol to testosterone ratio. So if more estradiol is produced, we've got this feminization in males. And then again, symptoms here, amenorrhea, which is either absence, or we've got oligomenorrhea, which is partial absence of menstruation, so it's very irregular. So then we've got hirsutism, which is increase in androgen and causing excessive hair growth in females, as well as this virilization, which is excess testosterone in females, which develop male features. So it's kind of a more serious continuation of hirsutism. And the most common cause of this is PCOS, which is polycystic ovary syndrome, where we see these polycystic ovaries in a woman's reproductive system, but they're not actually this, they just look like them. Then we've got Klinefelter syndrome, and it's genetic, and this is where the males get an extra X chromosome on this XXY, and that usually results in a low androgen production because the X chromosome precedes the Y, and we've got more estrogen production, and it results in infertility. We also have this, similarly to Laron syndrome, we've got this androgen sensitivity syndrome, where mutation in androgen receptor gene, so the hormones can't properly work. Again, we've got this Turner syndrome, which is congenital, so development in the fetus, hypogonadism, and that's loss of the second X chromosome in females, and we get this very distinctive short web neck feature in females. Then we get this PCOS again, elevated testosterone and irregular periods, and we get these polycystic ovaries. That was a quick overview of the gonads, what they do, how they're formed, and yeah, that's basically it for the hormones, and that's where we finish our series on biochemistry. So yeah, that's basically what we've done, and yeah, hope you enjoyed. Like and subscribe, don't forget to check the description for links if you want to try anything from Amazon for free, and yeah, I'll see you in the next one. Cheerio.